So what should we do when we have an imbalanced data? First thing is to get more data. That's clearly better, but usually this is quite expensive. You collected the data and then you find out it's imbalance, and then do I have to gather even more data? It will take time. You have to do some effort. Maybe actually you have to pay some money. So this is a better. This is clearly the better result. But sometimes it's expensive. So how can we resolve this problem? It's oversampling or undersampling, or waiting on the loss function. So oversampling means, as you can see, for example, 95% is the yes, and then no has only 5%. And oversampling means we will sample from here more and more. I can collect the more from the no's. Okay, so make it balance. Here you cannot make a 50-50, but I will be fine. It's like a 70-30 or 60-40. This is oversampling. I can collect more data from the small portion. Undersampling is I will use all of these nodes, but I will select only few here. Few selection. So 95 up here, so I collected the 5, all of them no, I will use all no's, and then I will collect only 5%, I mean the same number of yes from here, randomly sample. This is the undersampling. So undersampling is easy, even though I have a lot of them. So I collected like 95 of the data of yes, the student information, 95 of student information who said yes, and I have only 5 students who said no. Then I collect only 5 here, and then all 5 here. So now I have a 50-50 y and yes and no, 50-50 data. So using this data, now this is the balanced data, you can make a model. So no problem. And then this is a pretty easy, right, to imagine. Out of 95, I will randomly collect just 5 and then make it balanced. But what is oversampling? Do I have to just sample the same person again and again? No, not about that. I will show you what is the oversampling next slide. And then also weighted on the loss function is you give a penalty. So again, these things is also used in any machine learning model. Weight on the loss function is when you have some kind of penalty, when you have a wrong prediction, you give a different weight. So if you miss the yes, you give you lose. Penalty is pretty small, but when you miss the no, then you give a pretty high penalty. So you give a small penalty here, and large penalty. Then the model, trying to minimize the penalty, then model will spend more trying to predict this no more accurately, right? So when you train using this loss function or penalty function, if you give a high penalty on the no prediction, if it's a false no, then you give a high penalty. Then the model will, during the training, model trying to reduce the false negative. So automatically the model will become trying to predict little more no's accurately, but you will lose a little bit of the accuracy on the yes side. So you can just change in even though using the imbalanced data, your model will move toward trying to making more effort to predict the no side. So yeah, oversampling. How can I sample more from the limited number of information? Um, this is a synthetic minority oversampling technique. So of course we are oversample from minority. So undersampling is just we just reduce the number of the positive, the blue one. I will use all the orange one here, but I select only few. This is undersampling. But oversampling, using the small number of data, I have to create a lot of data. This is oversampling. But how can I create the copy in this way? So this is the data. You created any random point in between here. So it should be different from the blue dots, right? So you have to just create the data in the middle point, right? So you can select the randomly 2 or 3 point and then you decide the middle point. You randomly selected this and this and this, this and this and this, and then choose the middle point. This way you created actually the fake data. This is the we call it the synthetic samples. This is not the real one. This is the fake data. But since we created using the real one, we assume this is the close to our real data enough. And now I creating more. So now the number of the blue dot and number of orange dot are similar. And this is what we call is oversampling. Okay, this is the just we choose the certain number of the neighbors, so from the minority data, and then you can just select the middle point, and you created some fake data, and that's how you created oversampling. So originally this is like, as you can see, the most of them are the blue data, and orange data just few. But if you use this synthetic minority oversampling technique, and you can just create a lot of the data in between the orange data, and then you created way more. So now you can resolve this imbalanced problem. Okay, that's the end of the slide. And again, this from the middle of the slide is like the performance measuring is also widely used in the machine learning techniques, not only the statistical model.